Percentage basics. Before we get started with percentages, let's look at 5%. 5% is equivalent to 0.05, and it's also equivalent to 5 over 100. Keep in mind that when we went from 5% to 0.05, we moved the decimal 2 spaces to the left. When we moved it into 5 over 100, we just took that number and just put it over 100. And we're going to come back to the idea of 5% over and over again throughout this lesson. Finding a percentage. The percent is the part over the whole. That's a good phrase to keep in mind when you're trying to figure out the percentage of something. For instance, there are 24 cupcakes in a bakery display case. 10 are chocolate, the rest are vanilla. What percent are chocolate? Like we said a moment ago, the percent is the part over the whole. In this situation, it's the part of the group that are chocolate over the whole group. So that's 10 that are chocolate divided by 24. 10 over 24 is 0.4167. And if 0.05 is 5%, that means we move the decimal 2 spaces to the right. And 0.4167 becomes 41.67%. Next problem. There are 95 sheep in a herd. 3 are black sheep and the rest are white. What percentage of the sheep are white sheep? Well, if there's 95 in the herd and 3 are black, 95 minus 3 would give us 92. So therefore there are 92 white sheep. And the percent is the part over the whole, so we need the part of the group that has white sheep in it, that's 92, over the whole group of sheep, which is 95. Put that in a calculator, you get 0.9684. And as we said before, to go from the decimal to the percentage, we had to move the decimal 2 spaces to the right. So 0.9684 becomes 96.84. Next problem. 450 out of the 895 motorcycles that a dealership sold were cruisers, and the rest were sport bikes. What percent were cruisers? Once again, the percent is the part over the whole. Now we're looking for the part of the group that are cruisers over the whole group. And there are 450 cruisers, that's the part that are cruisers. The whole group is 895. Comes out to 0.503. And if 0.05 is 5%, then that means we have to move the decimal 2 spaces to the right. So 0.503 is 50.3% when you move the decimal 2 spaces to the right. On a certain day, 870 of the 2,000 cars that passed through a police checkpoint were late model cars. What percent were older model cars? Well, first of all, if we want to know the number of older model cars, it's the whole group minus the number that are late model cars. So 2,000 minus 870 gives us 1,130. So there are 1,130 older model cars. Now the percent is the part over the whole, the part that are older over the whole group. So we get 1130 on the top, 2,000 on the bottom. On a calculator, this divides to 0.565. Move the decimal 2 spaces to the right again, and it's 56.5%. In a town, if 750 out of 900 people voted in an election, what percentage of the people voted in the election? Once again, percent is the part over the whole. We need the part of the group that voted over the whole, which is 900. And put that in a calculator, you get 0.833. Move the decimal 2 spaces to the right, and that becomes 83.3%. A scientist is examining a sample for cells with a special DNA mutation. Out of 10 million cells, 3 have the mutation. What percent have the mutation? The percent is the part over the whole, so in this situation, the part of the group that has a mutation is just 3. The whole group is 10 million. When we divide that on a calculator, we get a situation where there are 7 zeros ahead of the 3. That's a really small number. But in this situation, it's going to be particularly easy to forget which way to move the decimal because we have such a strange number. So this is a situation where we really need to ask ourselves, what would we do if we had 5%? If we had 0.05, that would be equal to 5%. So to get from the decimal form to the percentage form here, we move the decimal 2 spaces to the right. So in this situation, we're going to move the decimal 2 spaces to the right. That gives us a situation where you have a decimal and 5 zeros before the 3. So it's 0.000003%. Now, if that number doesn't look funny enough, it may be put in scientific form in order to get it to look more like numbers look in the scientific world. So to do that, we'd have to move the decimal 1, 2, 3, 4, 5, 6 spaces to the right. Since we started with a really small number, that means it's 3.0 times 10 to the negative 6th. Still a percent. Next problem. A dance club has a capacity of 600 people. On New Year's Eve, the club was packed with 950 people. What percent over capacity was the club on New Year's Eve? The percent is the part over the whole, but this is an interesting problem because no one ever said that the part had to be smaller than the whole. Here, there are 950 people in the club, but the whole capacity of the club is 600. So you get a situation here where the part, in theory, is bigger than the whole. And that actually makes sense because that's going to give us a percent that's over 100. When you divide it out, you get 1.583. Now once again, if we had 0.05, that would be 5%. So we had to move the decimal 2 spaces to the right. So right here we're going to move the decimal 2 spaces to the right to get from decimal to percentage form. And 1.583 becomes 158.3%. And in a situation where you have a part over the whole, and the part, the numerator, is bigger than the denominator, the whole, this is going to give us a percent that's greater than 100%, which is very common. Next problem. What percent of 500 is 60? Percent is the part over the whole, 60 is the part, and 500 is the whole. That gives us 0.12, and we need to move the decimal 2 spaces to the right, and that gives us 12%. Taking a percentage of a number. This is very different than finding a percentage because when you're finding a percentage, the answer would have a percent in it. In other words, I have a certain number of objects out of some whole group. What percent is that? The answer might be 15%, or in the last problem 12%, or in the problem before that 158%. Now we're taking a percentage, different from finding a percentage. When you take a percentage, you know what the percent is, you may know what the whole is, and you need to find out what number that percentage is equal to. In this situation, the decimal is going to be moving 2 spaces to the left, not to the right this time, which makes sense because if I had 10%, that would become 0.10 when I move the decimal 2 spaces to the left. Or in the example we've used a bunch of times, 5% becomes 0.05. Once we move our percentage from percentage form into decimal form, now all we have to do is multiply the amount that we're given by that decimal. So let's practice that. What is 15% of 45? We're going to move the decimal 2 spaces to the left and then multiply 0.15 by 45, which equals 6.75. What is 25% of 22? Move the decimal 2 spaces to the left. 25% becomes 0.25. 0.25 times 22 is 5.5. What is 27% of 36? 0.27, because we move the decimal 2 spaces to the left. 0.27 times 36 equals 9.72. 45% of the dogs that come into an animal shelter are female. If there are 2,500 dogs, how many of them are female? So our percentage is 45%. We're going to move the decimal 2 spaces to the left. That becomes 0.45. And we're going to multiply it by our whole number, 2,500. 0.45 times 2,500 equals 1,125. 25% of the products a factory produces are consumer products, and the rest are commercial products. If the factory produced 25,600 total products, how many commercial products did it produce? First of all, we need to realize that if 25% of the products are consumer products, out of the 100%, we can subtract that 25% and realize that 75% of the products are commercial products. Now, to get the decimal form of 75%, we move the decimal 2 spaces to the left, so 0.75 times the total, 25,600, gives us 19,200. So there are 19,200 commercial products that the factory is producing. Moving the decimal right versus left. First of all, don't underestimate this question. Just like many concepts on the SAT that look very easy, when you get into different applications of it, it could actually be quite challenging. So, for instance, if we had 5%, that would become 0.05. That means we took the decimal, we moved it 2 spaces to the left. 34% becomes 0.34. We took the decimal, we moved it 2 spaces to the left. If we had 0.56 after solving an algebraic equation, we could say that that equals 56% because we're moving the decimal 2 spaces to the right. 0.01 could be 1% because we also moved the decimal 2 spaces to the right. Now let's get into some trickier applications of this. If we had 0.04%, we need to look back at the 5% and say, when I turn 5% into 0.05, I move the decimal 2 spaces to the left. So 0.04% is going to become 0.0004 after moving the decimal 2 spaces to the left. If I had 5,647%, once again, when we went from 5% to 0.05, we moved the decimal 2 spaces to the left. So we'll move it 2 spaces to the left here, and it becomes 56.47 in decimal form. Now, if we had 0.004 in decimal form, and we needed to get that into a percent, well, to get from 0.05 to 5%, we move the decimal 2 spaces to the right. So let's move it 2 spaces to the right, and 0.004 becomes 0.4% in percentage form. If we had 30,000, if that were somehow a decimal form of a percentage, we need to get that into an actual percent. So to get from 0.05 to 5, we move the decimal 2 spaces to the right. So in this situation, we need to move the decimal 2 spaces to the right, and what we get here is 3 million %. Now into some algebraic applications. What's a percent? Well, if 5% is 0.05, you would think about taking a decimal and moving it 2 spaces to the left. But that doesn't work because a could be a number with 1 digit or 2 digits. So it doesn't lend itself that well to moving the decimal 2 spaces over. So we need to also think about the meaning of a percent. Percent means for 100. So it's every part over 100. So a percent is just a number over 100. So a percent would be equal to a over 100. Therefore, for k percent, we couldn't take the decimal and move it 2 spaces over in this situation because it's a different type of situation. So if we had to express that percentage, we could call it 4k over 100. For a over 100 and 4k over 100, if we had to find the percent of something, we could multiply some whole number by a over 100 or by 4k over 100, just like we would have multiplied by 0.05 in previous situations. It would work the same way. Next problem. A family decides to give k percent of their income to their church. If the family members made a total of $105,000 in the first year and $112,000 in the second year, what is an expression for the total amount of money the family paid to the church? Well, what is the total amount of money that the family paid to the church? $105,000 plus $112,000, which equals $217,000. Just like we said a moment ago, if 5% is equal to 0.05, we could think about moving the decimal 2 spaces to the left. But with k percent, that's not going to work. So 5% being 0.05 is also 5 over 100. So k percent, since we can't do 0.0k, because that just wouldn't work, we have to use k over 100. But we can still multiply this against the whole to find the percentage of something. So k over 100 times 217,000 equals 2170k. So the expression for the total amount of money the family paid to the church is 2,170k. Reversing a percentage. This is very common on the SAT and in SAT prep books. If you're given the fact that a certain percentage is working in one direction, can you take that and figure out what's going on in the other direction? If I know that an item is growing by a certain percentage every year, can I find out what it was equivalent to in previous years? And that's something that I notice is frequently asked for on SAT tests. After the temperature went down by 85%, what must it increase by to return to its original amount? If the temperature went down 85%, that means that it's currently at 15% of what it originally was. So if I call x the original temperature, at this moment we're at 15% of that after the temperature went down. Let's see if you can follow this algebraic sentence. I have some amount, 0.15x. I don't even care how I got that anymore, but I have that amount and I need to multiply it by some number, and after doing that it's going to turn into x all over again. So in other words, what is that number I had to multiply by? Now we can just do our regular algebra to solve for that. Divide both sides by 15x to get y by itself, and on the right hand side the x's are going to cancel, leaving you with 1 divided by 0.15. In decimal form this turns into 6.6 repeated, which could be thought of as 667%. Now, if I am 667% of what I was before, what did I increase by? Well, I'm 100% of myself right now. So to get to 667%, we need to increase by 567%. So even though the answer in decimal form is 6.67, the answer to the question is 567%. For instance, if the temperature is 125% of what it was before, what did it increase by? It increased by 25%, because you always subtract out the 100% that you originally had. It's easier to see why you need to subtract 100 from the percentage if we look at a situation where the temperature was 70 degrees, it increased by some percentage, and it became 80 degrees. So if we had 70, we multiplied it by some number, and the result was 80, then we could go ahead and do the algebra to solve that. Divide both sides by 70, and 80 over 70 comes out to 1.143. So in other words, we had to multiply 70 by 1.143 in order to get 80. Of course, move the decimal over 2 places, and 1.143 is 114.3%. Let's think about this for a second. Obviously, 80 is only a small amount more than 70. So when I multiplied 70 by some percent in order to get 80, I was multiplying it by the 100% that I originally had, so I'm keeping my original 70, but I'm adding an extra 14%. So 70 plus 14% of 70 gives you 80. That's why, although the answer came out to 1.143, which is 114.3%, the increase was 14.3%. Similarly, on our last problem, although the number came out to 6.67, the increase was 567%, not 667%. Next problem. Each year, a company's stock value increases by 15%. If it was valued at $54.68 per share in 2012, what was its value in 2009? Let's just go ahead and say that X stands for the value in 2011. So if I had some value in 2011, and I increased it by 15%, in other words I multiplied by 1.15, then it became $54.68. If we divide both sides by 1.15 to figure out what X was, X becomes 47.547. So now we know that the value of the stock in 2011 was $47.58 roughly. So if we create another value called Y, and we say that the value in 2010 was Y, then we had that value, we increased it by 15%, multiplied by 1.15, and it equaled what we had the following year, 47.547. When we go ahead and divide both sides by 1.15, we get 41.35. So now we know that in 2010, the value of the stock was $41.35. Now let's take it a step further. We had a value Z that's equal to the stock in 2009. So we have our 2009 value Z. We increased it by 15%, multiplied by 1.15, and that came out to $41.35. To go ahead and get Z by itself, divide by 1.15 on both sides, and Z comes out to $35.95. So now we know that the stock value in 2009 was $35.95. Now let's practice turning percentages into algebraic expressions. 45% of X equals 62% of Y. What percent of X is Y? 0.45X equals 0.62Y. Divide both sides by 0.45, and x comes out to 1.378. If 0.05 is really 5%, then this decimal form 1.378, we need to move it 2 spaces to the right just like we did at the 0.05, and we get 137.8%. 50% of 18 is 10% of what number? 50% of 18 is 10% of some number x. Go ahead and get x by itself by dividing by 0.10 on both sides, and x comes out to 90. If 0.003% of x is 10, what is 8% of x? Well, if 5% turns into 0.05, then 0.0003% has to turn into a number where you move the decimal 2 spaces to the left. So now you have 5 zeros before the 3. So 0.000003x equals 10. Go ahead and divide by that on both sides, and x comes out to 3,333,333.3 repeated. Now, what's 8% of that crazy number? So 8% is 0.08 in decimal form. So 0.08 times 3 million whatever equals 266,666.6 repeated. Percent increase and decrease. The formula for percent increase and decrease is equal to the change over the original. Whether it's an increase or decrease really doesn't matter too much. A student who was struggling in history class hired a tutor. Her grade went from 68% to 93%. What was their percent increase? The percent increase is going to be the change over the original, and here the change is 93 minus 68. It's 25. So the original is 68. Now keep in mind here, you're going to be really tempted to put 93 on the bottom, because when you're doing percentages, the part over the whole, it's really tempting to just take the bigger number and put it on the bottom. I guarantee you the number that would be arrived at from getting 25 over 93 would be one of the test choices. 25 over 68 is 0.368, which we move the decimal 2 spaces to the right, becomes 36.8%. A football team won 15 games last year compared with 9 this year. What was the percent decrease in wins from last year to this year? Well, first of all, we need to know what the change was. If they won 15 last year and 9 this year, that means they changed by 6. So the percent decrease is the change over the original amount, which is 6 over 15, which comes out to 0.4. And so if it was 0.4, we need to move the decimal 2 spaces to the right, and that's a 40% decrease. A cattle farm spent $445,000 on its cost for the year. How much income does the farm have to earn to make a 16% profit? If we have $445,000 and we need an increase, a profit of 16%, we've got to multiply by 1.16 because we'll get our 100% back plus 16% more. When you multiply those together, you get 516,200. 516,200 minus 445,000 gives you 71,200. So the amount that they're making above and beyond the 445,000 they started with is 71,200. Now let's talk for a second about the number sense behind fractions. If I had 5 times 1, well, of course that equals 5. And we know that 1 is really the decimal form of 100%. Because if I move the decimal 2 spaces to the right, 1.0 becomes 100%. What happens if I multiplied 5 by a decimal, like 0.2? Well, 5 times 0.2 is 1. And 0.2 is really 20%. So 20% of 5 is 1. 5 times 0.4 is 2. And 0.4 is really 40. So 40% of 5 is 2. By 0.5 is 50%, which comes out to 2.5. Multiplying by 0.8, that's 80%. 80% of 5 is 4. We multiply 5 by 0.9, that's 90%, which is 4.5. So if we multiply by any percent in between 0 and 100, we're going to get fractions of 5. We're going to get parts of 5. In other words, numbers that are in between 0 and 5. If I multiplied by 1.2, really that's 120% if I move the decimal 2 spaces over. And the answer is 6. But let's look at that 6. That's equal to 5 plus 1. In other words, the 100% that I originally started with plus an extra 20%, because 1 is equal to 20%. If I multiply by 1.4, that's 140% of 5, and that answer would be 7, which is really 5 plus 2. So if I get 140%, I'm getting my 100% back, my 5, plus 40% more, which is 2. If I multiplied by 5, that would be 500% by moving the decimal 2 spaces over, but 5 times 5 is 25. But let's think for a second about what that is. 25 is really 5 plus 20. That's my original amount, 5, plus 4 more times the 5. So that's 100%, that's what I started with, plus 400% more. Next problem. 5 investors invested a total of $240,000 in a grocery store business. In a few months, the business's value increased by 35%. At the end of the period of time, the investors decided to sell the business and split its value equally. How much money did each person receive back? If they spent $240,000 and the value increased by 35%, we can say 240,000 times 1.35. Think about this. I'm getting my value back. That's the 1 or the 100, and I'm getting 35% more. Multiply by 1.35 and you get 324,000. Now the investors wanted to go ahead and get their money back, so you need to take that 324,000 and divide it by 5, and that'll come out to 64,800. Next, percent of a percent. This is something that's also very common on SAT percentage problems. What's 10% of 5% of 522? If we simply convert both of those into decimal form, 0.10 times 0.05 times 522, the answer is 2.61. What's an expression that's equivalent to A% of B% of C? Well, we can't say that A is 0.0A, so we need to use the fractional form of the percentage. A% is A over 100. B% is B over 100. And we're getting these percentages of C. Multiply that out, and you get ABC over 10,000. Next problem. On a dealership lot, 12% of the cars are convertibles. Within that group, 45% are hardtop convertibles. What percentage of the total cars on the lot are hardtop convertibles? If I call X the total number of cars on the dealership lot, 12% of those are convertibles. So 0.12x is talking about the number that are convertibles. I need 45% of that, so I'm going to multiply that by 0.45. The important thing is to realize that it's not 12% plus 45%, which would have been 57%. That's not what it is. I take my 12%, then I almost can forget what's inside the parentheses and multiply that by 0.45. Then I'm just multiplying the two numbers. A percent of a percent means you need to multiply everything together, and we get 0.054. Now, of course, if 0.05 is 5%, then 0.054, moving the decimal 2 spaces to the right, would be 5.4%. In a neighborhood with 2,560 residents, 20% are members of the independent political party, which has 2 candidates, candidate A and candidate B. 25% of the independent party members support candidate A. How many people support candidate A? If there's 2,560 residents, 20% of them are in the independent party. If 25% of those support candidate A, then the number of people that support candidate A is going to be the total people in the group, 20% of that, 0.2, and 25% of that, 0.25. Multiply all 3 of those together, and you get 128. Next problem. Of the 300 million people who live in the United States, 27.3% of them are under 20 years old. If 30% of Americans under 20 have a Facebook account, how many Americans under 20 don't have a Facebook account? One trick here is that 30% have a Facebook account, so we need to subtract that from 100 and know that 70% don't have a Facebook account. So 300 million people, and I'm going to take 27.3%, move the decimal over, so that's 0.273, and I need 70% of that. Multiply all those together and you get 57,330,000.